Hi, here we are again for a new video lesson in Mathematics 10 about polynomial function. So today we're going to discuss on the relationship between the degree of a polynomial, its number of zeros, and its number of turning points and end behavior. A degree in a polynomial function is the highest exponent of the function, which determines the most number of solutions in that particular function. The zeros of a polynomial function are the values of x where the function is equal to 0. It is also called as the roots. The turning points of a graph occur when the function changes from decreasing to increasing or from increasing to decreasing values. The end behavior of the graph of a polynomial function refers to the rise or the fall of the tails or hands of the graph. Let us first tackle the degree of a polynomial. The degree of the polynomial function will give us an idea on what will be the possible image of the graph of our polynomial function. If the degree of a given polynomial function is even, then the graph is similar to the graph of a quadratic function. This is a graph of a quadratic function, while this is a graph of a quartic function, a polynomial function with degree 4. As you can see, the left hand and the right hand of the graphs are at the same direction. If the degree of a given polynomial function is odd, then the graph is similar to the graph of a cubic function. This is a graph of a cubic function, while this is a graph of a quintic function, a polynomial function of degree 5. As you can see, the left hand and the right hand of the graphs are on different direction. Now let us tackle the number of zeros. Fundamental theorem of algebra states that a polynomial function p of x of degree n has at most n number of real roots. For example, p of x equals x cubed minus 6x squared plus 11x minus 6. Since the degree of our polynomial is 3, then there are at most 3 numbers of 0. And the zeros are 1, 2, and 3. Number of turning points. The number of turning points of a graph is determined by the characteristics of the multiplicity of its zeros or roots. If the multiplicity of a zero is odd, then the graph crosses the x-axis. If the multiplicity of a zero is even, then the graph is tangent to the x-axis. A polynomial of degree n will have at most n-1 turning points. For example, find all the real zeros and turning points of the graph of p of x equals x raised to 4 minus x cubed minus 2x squared. First step, factor completely. So we will have p of x equals x squared times the quantity x plus 1 times the quantity x minus 2. So our real zeros are negative 1, 0, and 2. For negative 1 and 2, the multiplicity is 1. The characteristic is odd. Therefore, the graph crosses the x-axis. For 0, the multiplicity is 2. The characteristic is even. Thus, the graph is tangent to the x-axis. This is the graph of the polynomial function. The graph shows that there are 3 turning points. Since the degree is 4, this is the maximum number possible. end behavior. Leading coefficient test. This is the test which enables you to discover the end behavior of the graph in terms of rising and falling. For example, p of x equals x raised to 4 minus x cubed minus 2x squared. Since the leading coefficient is positive, then the right tail of the graph is rising. This is the graph of our polynomial function. Let's now have an exercise and complete the table below. Direction. Describe the behavior of the graph of the function p of x equals x raised to 5 minus 6x raised to 4 plus 10x cubed minus 11x plus 6. The leading coefficient of our polynomial function is 1, that is greater than 0. The degree is odd, so the end behavior of our graph are the following. The left-hand side is falling and the right-hand side is rising. Therefore, the graph of our polynomial function falls to the left and rises to the right. Now let us answer the next table. Step 1. We need to factor our polynomial function completely. Thus, our p of x will be equal to the square of the quantity x minus 1 times the quantity x plus 1 times the quantity x minus 2 times the quantity x minus 3. Now let us fill in the table. For our zeros, negative 1, positive 2, and positive 3, the multiplicity is 1. The characteristic is odd. Thus, the graph crosses the x-axis. For our 0, which is positive 1, the multiplicity is 2. The characteristic is even. Therefore, the graph is tangent to the x-axis. There are at most 4 number of turning points in our polynomial function since the degree is 5. This is the graph of our polynomial function p of x equals x raised to 5 minus 6x raised to 4 plus 10x cubed minus 11x plus 6. I will give you 1 minute to apply what you have learned. You may pause the video if you need extra time to work on the task. Your time starts now. Now, let us check your answer by comparing it to mine. See if you got it right. Let's start with the leading coefficient test. Our n is greater than 0. The degree is even, so the end behavior of our graph is the left hand is rising, the right hand is also rising. Therefore, both hands of our polynomial function are rising. Step 1. Factor completely our polynomial function. That is, p of x equals the cube of the quantity x minus 1 times the square of the quantity x plus 1 times the quantity x minus 2. So for our zeros, we have 2 odd multiplicity and 1 even. For the zeros 1 and 2 which are odd, the graph crosses the x-axis. For the even multiplicity, which is negative 1, the graph is tangent to the x-axis. There are at most 5 turning points in our graph. This is the graph of our polynomial function p of x equals x raised to 6 minus 3 times x raised to 5 plus 6x cubed minus 3x squared minus 3x plus 2. It's time for your individual activity. Now it's time for you to work alone. Answer the given problem independently to assess your learning. You may pause the video for you to have more time to work on the task. Problem set. Describe the behavior of the graph of the function p of x equals x raised to 5 minus x raised to 4 minus 2x cubed plus 2x squared plus x minus 1. Thank you for watching our video lesson for today. See you in the next video. This is Teacher Mabi signing off.